Okay, so I really took quite a shortcut today with the quotient rule. I just gave you this part. I didn't even mention that g of x can't be equal to 0, because that would have caused division by 0. So here's the quotient rule in all of its glory. It says if f over g, the quotient f over g of two differentiable functions f and g is itself differentiable at all values of x for which g of x is not equal to 0. Moreover, the derivative of f over g is given by, and then this is my low d high stuff, the denominator times the derivative of the numerator, low d high, minus the numerator times the derivative of the denominator, high d low, all divided by low squared, the square of the denominator. So, sorry about the sniffling. I am definitely coming down with something. So, that is just the quotient rule in all its formality. So, let's practice one. Let's find the derivative. Of, this is example 5, well, let's take it one step at a time. F of x equals 3 minus 1 over x plus 5. So I have a quotient, and if I want to find its derivative, I'm going to have to use the quotient rule. And I just want you to say it as you write it. It's low d high, I guess it's h-i-g-h, minus high d low, and every time you see the d, that's derivative of the low, over low squared. So low is x plus 5. We'll use parentheses because we're doing a whole lot of multiplying here. The derivative of the high, the derivative of the numerator, let's actually rewrite that numerator just a teeny bit. Let's change that to 3 minus x to the negative 1 over x plus 5. Now it's in a friendlier form so that we can take its derivative more easily. So the derivative of the numerator, the derivative of 3 is 0, and then it's minus the derivative of x to the negative 1. That negative 1 comes down in front of the x, and the x's exponent goes to the 1 less. So it's that. So we've done low d high. Now we'll do minus high. So we just write down the numerator. I'm going to go with the simplified version. D low, we're going to take the derivative of the denominator. Derivative of x is 1. Derivative of 5 is 0. All over the low squared. Now on this, let's see, let's just clean it up a little bit. We got x plus 5. This term right here would be just x to the negative 2 minus 3 minus x to the negative 1 over x plus 5. So it's kind of a mess, but what I actually want to do, the next step, is to find the equation of the tangent line through negative 1, 1, or at negative 1, 1. So if we found the derivative, I asked you to find the derivative. We also know the derivative is the slope, so we know the slope. That whole mess is the slope line. I'm actually not going to try to simplify that because at this point, the x value is a negative 1, so it's going to be fairly nice to do, even though this is a big yucky mess. We're just going to do the slope is the derivative at negative 1 equals, and we're just going to put a negative 1 in all these spots here where these x's are. Okay, So we're going to get negative 1 plus 5 times negative 1, negative 1 to the negative 2 minus 3 minus a negative 1 to the negative 1 over negative 1 plus 5 squared. Excuse me. I'm yucky. So cleaning this up, we've got a 4. Negative 1 to the negative 2, that's like 1 over a negative 1 squared. It's 1. The whole value is just a 1. Minus 3 minus this negative 1 to the negative 1. That's 1 over negative 1 to the first, which is a negative 1. All over 4 squared. So that's 4 times 1 minus this right here is just 3 minus a negative 1, or 3 plus 1, all over 16. And 0 over 16 is 0. If you are still finding yourself getting confused on whether this is 0 or undefined, I like to think if 0 is under, it's undefined. But if you don't like that, then just plug that into your calculator and just be sure it's 0. Or just think 0 divided by anything is 0. So that was the quotient rule. The other thing that might happen is we might have a product where we need the product rule. And I'm taking a picture of it from our book. It says the product of two differentiable functions, f and g, is itself differentiable. Moreover, the derivative of fg is, in this statement here that they've written, this is what I say to myself just about every time I do it. It's the first function times the derivative of the second one plus the second function times the derivative of the first. And I really say that almost every time. It's the first times the derivative of the second, first times the derivative of the second, plus second, I shouldn't have used yellow, times the derivative of the first. I'll write it better here when we work one. So let's use the product rule to find the derivative. So we're all over the place because example 1 is actually product rule. So if f of x is 3x minus 2x squared times f plus 4x. Okay. I have two things that are getting multiplied together, and each of those things are nice differentiable functions. They're both polynomials. So if I want the derivative, I can use the product rule because this is a product. So the product rule is first times the derivative of the second plus the second times the derivative of the first. Now we're not really using proper symbols here, but it's just for us to get this memorized. So when I write first, I don't change it at all. I just write it down. Just write the first function down. So now for d of second, we're going to take the derivative of this. Derivative of 5 is 0. The derivative of 4x is 4. So then it's plus. Now we're going to write the second. Don't change it, just write it down. We're going to multiply it by the derivative of the first. So we're going to take the derivative of this. 3 minus 4x. And you have taken the derivative with the product rule. In order to match the book, we're going to go ahead and distribute here. And over here we'll FOIL. And finally, we will combine like terms to simplify. And that is the derivative using the product rule. So let's say we wanted to make this equation, our function, a little more complicated by putting some trig in it. Instead of f of x, let's see, this one uses y. Well, that's intimidating all at once, but let's see if we can see it as two separate functions that are easier to take derivatives of. So when we go about this, we'll do the first times the derivative of the second. Derivative of sine is cosine. Plus the second times the derivative of the first. When you do the derivative of that, it's 6x. Or it's 3 times 2x. And there's not a whole lot of simplifying we can do. We could just sort of drop the parentheses. And there's our answer. I don't think I want to do that one. I think we will call that a good day. That's enough for us to practice for this weekend.